Another reactions in which alcohol is showing acidic behavior. Alcohol with Grignard reagent. We know what is Grignard reagent. The general formula is RMgX. Mg magnesium, X is representing halogen, chlorine, bromine, iodine, and R is representing alkyl part. Between R and Mg, we know R is made up of carbon and hydrogen. So carbon has made bond with magnesium, that is covalent bond. Carbon electronegativity is more than magnesium. So these electrons are more toward carbon side. So it is carrying negative charge. Magnesium have +1 charge, which is balanced by -1 charge of X. Between Mg and X, there is an ionic bond. Means electrostatic force of attraction is there. Positive, negative, they are just attracting each other. Ionic bond we call it. And between carbon and magnesium, there is a sharing of electron, which we call covalent bond. Now, due to higher electronegativity of carbon, electrons are more toward carbon side. That's why it is a negatively charged particle. So now this particle will react how with alcohol? Let's check. As we know, general formula of alcohol is ROH, in which oxygen is more electronegative than hydrogen. So these electrons are more toward oxygen side. So oxygen is carrying a negative charge and hydrogen is carrying partial positive charge. Whereas in Grignard reagent, also we know this is ionic bond, a strong bond. And here we have covalent bond, in which electrons are partially shifted toward R side. That's why it is getting -1 charge. So it's a weak covalent bond. Now when reaction will happen, bond will break between R and Mg. And how? Both electrons will obviously go toward carbon, because carbon is more electronegative than magnesium. So a negative particle is there which will attack on positive particle. In alcohol, who is a positive particle? H positive. So this R is going to attack on this H. Between oxygen and hydrogen, bond will also break and both electrons will get shifted toward oxygen, because oxygen is more electronegative than hydrogen. So from here, O negative will generate, because it has got one extra electron of hydrogen. You can check. So one extra pair is there. One electron was its own, this one, and one electron it has got from hydrogen side, this one. So this is extra electron, so it is carrying -1 charge. Now, when oxygen has broken bond from hydrogen, so hydrogen will release out as a vacant orbital +1 charge particle, whereas when R has broken bond from magnesium, so R was in this condition, this one. R has got one extra electron from magnesium, one electron was its own, so pair of electron will generate around R, that is carbonyl. Carbonyl, lone pair is there, hydronium ion, vacant orbital is there, they can react well with each other, a dative bond will generate, and RH will generate out here, alkane. Alkane will generate out here. Watch carefully, main product. What about this? Magnesium has lost one more electron of its, so on magnesium, +2 charge will generate, and only one X is there, -1. Only one -1 cannot balance +2. So here we have one more -1. -1 more of oxygen, -1 of X will combinedly balance this magnesium. So this magnesium is going to make bond with oxygen. The side product will be ROMgX. ROMgX. Now, depending the nature of R, this is alkoxy magnesium halide. We will call it alkoxy magnesium halide. This is alkoxy part, RO. Alkoxy. Alkyl and oxygen. Alkoxy magnesium is there and halide is there. So this is side product, alkoxy magnesium halide. Let's understand this reaction with one exact example. Suppose we have CH3OH, methane 1-ol. Now this methane 1-ol is going to react with CH3MgBr. This is methyl magnesium bromide, a Grignard reagent in which X is Br and R part is CH3. As we know, it's a negative carbon because the electrons are more toward magnesium side. Here hydrogen is positive because electrons are more toward oxygen side. That's it. We know this CH3 is going to combine with H and this O negative will be attacked by magnesium. So the products will be, first product CH4, CH3 and H will combine, methane. How bonding will happen already we have understood in mechanism, and this oxygen with 3 lone pairs is going to make bond with MgBr like this. Now as I said, its general name is alkoxy. We will not use alkoxy word here because now we have a particular alkyl group, methyl. So we will call it methoxy. Methoxy magnesium bromide. Methoxy magnesium bromide. Similarly, if we have, suppose this reaction with this one, so what will be the result? Let's check. This is Grignard reagent. This carbon have a negative charge. Be careful which carbon we have to use for attack. In previous videos I have also told to you the carbon which is directly connected with magnesium, that carbon you have to use for the attack. This is H positive, this will attack on it. So the main product generated will be CH3, CH3. This CH3 as it is. Now this CH2 will get one more hydrogen. The CH3 it will be ethane it is. Side product, this oxygen will be combined with magnesium. This. Now this part will known as ethoxy. The general name is alkoxy, but what alkyl group we are using? A particular alkyl group is there, that is ethyl. So we'll call it ethoxy. Ethoxy magnesium bromide. Now you can check in these reactions, alcohol is losing H positive. Am I right? Alcohols are losing H positive there. Loss of H positive indicating their acidic behavior. So this reaction will also come in the category of acidic reactions of alcohol. That's it. This is the end of the video. Please check the mechanism and try different reaction based on this case. Thank you very much.